So now it's time for us to start rendering out the cool effects that we just generated. The first thing that I'm gonna do, I'm gonna just fix a couple of things here. If you notice, there's a slight gap here between the small rays and the original ray. So the fix for that is pretty straightforward. So we can go here to the Thunderbolt main, and this is where we're merging everything together. So these are the small ones, and this is the big one. What we can do is we can actually snap these points. We can snap them to the surface before we actually copy the lines into those points. So we can, for instance, use array. And here I'm just gonna say, let's say display surface. Let's connect this one here. So this will be the final shape of the ray. And here on the ray, all we have to say is minimum distance. Okay, and that way the points will snap to the surface. When we copy the points there, we shouldn't see any gap anymore. Okay, pretty easy fix. I'm going to do the same thing for the Thunderbolt head. Just making sure that we have that settled as well. So let's create a array. I'm going to put it here, and the last version goes here, and we switch this to minimum distance, and that way we won't have any gap. These are actually much thicker, so I'm gonna go here to the set width, and I'm gonna lower the maximum width 0.8, just so they're more consistent. Yeah, I think that's going to work. We're going to be focusing on frame 10. We have both rays hitting, and this should be a nice render. And that's it. Now, let's turn this one on as well. And right now, I applied a shader here just so that it appeared like this on the viewport. Okay, just so we could see it pretty bright on the viewport. Let's switch back to the camera. But we're not going to be using this. The first step when you're trying to develop a shader usually would be to create a lighting setup, but in this case, most of the effects will be kind of self-illuminating, so that's not a concern right away. And since we're going to be starting with the Thunderbolts, with the main rays, that's definitely not an issue. But we do need to make sure we have a mantra node to render these out. So I'm going to go over to the out context, and here I'm just going to type mantra, and this will create a mantra node, and this is where we're going to be rendering. Now this mantra, you need to select the camera. So here I'm going to go, you should go all the way inside here. So this is the camera node that you need to select, accept. So that's the camera. And the next step, for now, we're just going to be rendering the current frame, which is going to be frame 10. The next step is going to be for us to go here to rendering. We're going to switch the rendering engine from ray tracing to physically based rendering. Nowadays, it's kind of the standard. And going over a couple of things here, just quickly explaining how this works in terms of how do you control the quality. Right now, the pixel samples is at default value of 3 by 3. This is the main parameter to control the quality of your final image. If you hold the cursor over the parameter, it's going to give you a very brief but very clear explanation about what it does. Essentially, this is going to be multiplying all the other samples that you do, that you have control over. By default, the ray variance anti-aliasing is also on. This means that instead of setting up a fixed value for the rays, okay, you only have one value. With this variance on, you can actually work with between these values. You have a minimum ray samples, a maximum ray samples, and Mantra is going to go calculate your image and go over that amount of samples based on this threshold. Whenever it doesn't meet the threshold, it will increase the number of samples. If it still doesn't reach the threshold that you set, it's going to keep increasing the ray samples all the way up to 9 multiplied by the pixel samples of 3. Okay, so these 3 plus this one will work together to control the quality and the amount of noise you have on the image. There are other controls that we'll be looking at, but for now these are the most important ones. Right from the start, what I'm going to do is kind of lower these just so we have quicker renders. So I'm going to say the minimum sample is going to be 1, maximum is going to be 4, just so it's a bit faster to render. The other area that is really relevant here, the other tab inside Mantra, is the objects. So this is very important because right now, and these are the default settings, the candidate objects has this symbol, an asterisk, and here as well, candidate lights. This just means that it's going to be considering everything that's turned on and visible. Okay. Usually this is not where you want to work because let's say I'm going to rename this mantra. So this is going to be the mantra for raise main. Okay, this mantra is going to be specifically for rendering these elements. Okay, so what we do is instead of using considering everything that's available, we're going to be forcing certain objects. So this should always render out the main head, the main thunderbolts, which is the thunderbolt head and thunderbolt main exact pattern, and we don't want to use any lights for now. Okay, that way even if you have Iron Man visible, he's never going to be showing up. Okay, it's never going to be rendering out. We'll only be considering these two objects. So we can go now to the render view here, select our mantra raise main. The camera, this option, the ROP camera, is gonna, it just means it's gonna be rendering out whatever is in the ROP operator. Okay, in this case it's gonna be this one. This means it's gonna auto update based on any change you make to geometry or material, and it's gonna auto update, and this just means it's progressive. For now we can just leave it in like that. And if we press render, we should see the rays. So these are the rays that we have with the material that I just previously created.